All right, my Algebra 3 peeps. I'm here with my esteemed colleague Griffin,
Hello.
and we're going to go over this homework with you right now. Okay, so there's 12 months in a year. Find the probability that a month begins with J. What months begin with J? January, June.
July.
There we go. July. So that's 3 months out of 12. Make sure you reduce. That's 1/4. The month begins with A, so that's April and August. So that's 2 months out of 12, which reduces to 1/6. Last but not least, the month begins with B. Does any month begin with B?
No.
Bobtober? No, nothing does. So probability is 0. Done. If at any moment you have questions, pause the video, replay the video, and do what you need here. If you roll a standard 6-sided die one time, what's the chances of rolling a 4? 1 out of 6. What's the chances of rolling a number that's not a 6? Well, there are 5 numbers other than a 6, so that's 5 out of 6. What's the chances of rolling a number less than 5? So that's 1, 2, 3, or 4. That's 4 numbers out of 6, which is 2/3. Not negative 2/3. That's an equal sign right there. Probability of rolling a 7. If there's only 6 numbers on a die, what's the chances that I roll a 7?
0.
That's right. What's the chances that it's odd? Well, there's 3 odd numbers, and there are 3 even numbers. So both of these answers will reduce to give you 1/2 each. I don't want to confuse anybody. This is 1/2, and this is 1/2 right here. Okay, pause if you have any questions on that. Standard deck of 52 cards. I attached a reference sheet for you to look at. Please print out that reference sheet if you are not familiar with cards. That reference sheet has all the breakdowns of cards. What's the chances that the card is a black card? That's half the deck. 26 cards out of 52 are black, 26 out of 52 are red, so that's 1/2. What's the chances of a 1? Some games consider the ace a 1. Do not consider the ace a 1. There is no card that has the number 1 on it, so that is 0. A face card, those are the jacks, the queens, and the kings. And there are 4 jacks, 4 queens, and 4 kings. So that is 12 cards out of 52, which reduces to 3/13. That's a 3, sorry. An even number on it. So that's the 2s, the 4s, the 6s, the 8s, and the 10s. And recall, there are 4 of each card. 4 2s, 4 4s, 4 6s, 4 8s, and 4 10s. So that's 4 plus 4 plus 4 plus 4 plus 4 cards. That's a total of 20 cards out of 52. And 20 out of 52 reduces to 5/13. Again, apologies for the sloppiness. I'm trying to write as neatly as I can on the screen. There are 4 6s in the deck, 4 cards out of 52. That reduces to 1/13. Reduce whenever you can. 4 goes into 52 13 times. Heart is one of the 4 suits. So that's 13 hearts. There are 13 cards that have hearts on them out of 52, which reduces to 1/4. Last but not least, there are 4 aces in the deck out of 52 cards, and that reduces to 1/13. And there's the card breakdown. Cannot stress this enough. Please use the card distribution on the reference sheet that I provided to you. Print it out or have it just somewhere on your laptop that you can toggle between, because you will be able to use that reference sheet when doing these types of problems. Given the digits 1 through 9, what's the probability that the digits are even? 2, 4, 6, and 8 are even digits, so that's 4 out of 9 numbers. Okay, and a digit that is less than 3, that's just the digits 1 and 2. So that's 2 numbers out of 9. Number 5, 2 questions left. Find the probabilities of the following if you roll 2 standard 6-sided dice once. So for this problem, you can consult your reference sheet once again and use your 2 dice chart with the 36 possibilities that we actually showed and worked on during the lecture itself. The probability that the sum equals 12. And on that 2 dice chart, please have it in front of you. There's only one sum of 12 out of the 36 possible sums. What's the probability that the sum is 1? You could roll a 1 on either one of the dice, but you can't roll a sum of 1. So the probability there is 0.
Yeah.
Can't do it. And what's the probability that the sum equals 4? Everyone look at your 2-dice chart. Look at the diagonals of the 2-dice chart, and you'll see that the diagonals produce the same sums. How many 4s do you see along the diagonal on the top left? Do you see 3 of them? That would be correct. There are 3 ways to roll a sum of 4. A 3 and a 1, a 2 and a 2, or a 1 and a 3. So that's 3 ways out of 36, which reduces to 1/12. What's the probability that the sum is less than 5? Count up the 2, the 3s, and the 4s. And there are 6 possible ways to roll a 2 or 3s or 4s out of 36. So that's 1/6. And then last but not least, what's the probability that the sum is an odd number? In that 2-dice chart, half of the numbers are odd, half of the sums are odd, and half of the sums are even. So 18 of the 36 sums are odd, and so that reduces to 1/2. Pause if you need, review if you need. Look at your 2-dice chart, okay, before moving along. Down to the last question, number 6. What's the chances of rolling a red, or pulling out a red marble? First and foremost, you have to think about how many marbles there are. 4 plus 3 plus 5 plus 8. That adds up to 20 total marbles. So our denominator for this question will be 20. What's the chances of choosing a red marble? 4 out of 20, which reduces to 1/5. A green marble, that's 8 out of 20, which reduces to 2/5. Blue marble, that's 3 out of 20, which does not reduce. And the final question on the homework, that it's not white. Well, if 5 of the marbles are white, what's 20 minus 5, Griffin?
20 minus 5, 15.
That's right, so that's 15 out of the 20 marbles are white, and that reduces to 3/4. That's the homework, everybody. We'll see you for the next lesson.
Bye.